Hello, welcome to our webinar. Our speaker today is Rafi Kurlansek. He's going to be talking to us about a very interesting use case. So we had an internal contest at IBM recently, and multiple people participated, and Rafi won with this use case, which is pretty much looking at Airbnb data, trying to find some pricing inefficiencies, and then being able to price your property in a way that optimizes your revenue. So with that, let's get started. Rafi?
Thank you, Anna. Hi, everybody. Thank you very much for joining us today and taking some time to go over this use case that I implemented on Data Science Experience. We're going to be talking about how to predict Airbnb prices in Portland, Oregon. And there's not going to be too many slides. It's mostly going to be going through the platform and the actual substance of the analysis. So let's get started. Okay, so our agenda today is I'm going to introduce myself, give you some background about me. We'll talk a little bit about the machine learning challenge that we had here at IBM, the criteria for it, and some details about the solution that I came up with. Then I'm going to segue a bit and just provide context on what IDE I used, what development environment I used for the solution. So I'll talk about Watson Data Platform and specifically the Data Science Experience. Then I'll actually go into the whole analysis itself. That'll take up the bulk of our time. Then we'll just review what we did, the end-to-end solution that I did, and then conclude, and hopefully we'll have time for questions. Okay, so about me. I am Rafi Kurlansek. I live in Cherry Hill, New Jersey. I graduated with a Bachelor's in Science of Nursing from Adelphi University in 2008. And I actually never became a nurse, and I decided to take the opportunity to trade oil and gas futures on the New York Mercantile Exchange for 7 years. What I noticed, and why this is relevant to my current position, is that the financial markets changed very, very quickly in the span of a couple of years, and the volume of trades placed went from having humans be the majority of actors in the financial markets to being a very small minority. And what was replacing human traders were machines, and specifically computers being driven by machine learning. So I sort of saw this as I saw the importance and the disruption of machine learning firsthand, and decided that I would re-educate myself and learn how to be part of that wave. So I did the Johns Hopkins Data Science Specialization. I completed that at the end of 2015, beginning of 2016, and I was very fortunate enough to land my current position with IBM in last July 2016. So my role right now is focusing on all of IBM's cloud analytics services and software. So we're going to be focusing on data science in this topic. Okay. And yes, this is me actually trying to smile in that picture. Okay, so what was the challenge? What were the constraints of this this internal challenge we had at IBM? So it's pretty simple. Demonstrate the value of machine learning by solving a business problem by using real-world data. So it can't be like a synthetic data set. It has to be actual real-world data. We also had to use Data Science Experience. The data set had to be publicly available. So it's not something you can't use data that you had to pay for or something like that. And the analysis itself had to be done in a Jupyter Notebook in a way that could be shared and reproduced by other data scientists or other analysts. And then the real kicker was that there was only 2 weeks to do all of this. So it was 2 weeks to try and get something that looked nice, solved an interesting problem, and was compelling. Okay. So now, a couple weeks before I got this email that we're having this challenge, I had actually stayed at my first Airbnb. And I met my friend in Denver, Colorado. We went to a concert there, and we stayed at an Airbnb that was right across the street from the venue. And it was an awesome experience. This place had just a ton of character. It was way different than staying at a hotel. Just a much more interesting and enjoyable experience. So I sent my friend, who was not in Denver at the time, I sent him pictures of the place that we were in, and he could not figure out where I was, and you'll see why. This place is very interesting. So they had they had a lot of taxidermy in this apartment. They had this totally strange planter zombie, like inside the dirt of the plant. It was a really, really interesting place to stay. So that kind of this experience kind of had Airbnb on my mind when I got this email a couple weeks later. So what did I do? I defined the question, right? Business challenge was, well, how do I know if I'm getting a good deal as a consumer? And how should I price my property if I'm someone who owns a property and I want to rent it out? So the solution I came up with involved preparing the open data set, the publicly available data set. I trained a mixed effects regression model that was sensitive to both the location of the property and the size of it. And then in terms of defining, what's a good deal and what's not, I used confidence intervals, and any price that sort of went beyond the confidence intervals, I would consider those mispriced. And then another thing that I incorporated that you'll see in a bit is that I sent the reviews for the properties to Watson via REST APIs, and use that to sort of get a quick picture of what people are saying about these properties. So what are the benefits? As a renter, you can obviously pick a property that you get the most value for your money, and as an owner, you can input your the specs of your property and then sort of compare how it should be priced relative to the neighborhood or the market. I think that obviously this is a real estate kind of problem, but I think it's a broader problem of how do you price a commodity in a competitive market. So if you have problems that sort of fall into that scheme, or you have an asset that you want to sell and you're not really sure how you should approach it, I think that this template can be applied in other industries besides real estate. As I mentioned, I used mixed effects regression models, and I actually did some clustering that you'll see. Everything is written in R, and the data source was from the Data Science Experience community tiles that I'll show you. It was actually originally published by a third party called Inside Airbnb, and I'll talk a little bit about that when we go through the notebook. Okay, and we'll take a look at the data when we get a little bit closer. Okay, so that's the machine learning competition, and about me. Let's talk about Watson Data Platform and Data Science Experience. Okay, so let's say you have this great idea for an app or a way to improve processes at your enterprise, and you need the tools to do it, right? You want to build a data product, but how are you going to do that? So you're going to need either one Superman who knows a lot of different languages and a lot of different processes, or more likely you're going to build a team. So at IBM, we see the advanced analytics team as being broken up into kind of like these 4 different personas. Each of them responsible for like a critical part of the life cycle of building a data product. So we'll start with the data engineer. Their primary responsibility is getting nice, clean data from the source into the hands of the analysts. The data scientist is the one who will dive sort of the deepest into the actual data and build models to answer the original question or help drive the value of the product with the greatest degree of accuracy. The business analyst will understand the place of the product in the larger business the most and maybe come up with the original idea to begin with. And then finally, the app developer has a slightly different skill set that might be centered around actually delivering and deploying the final product into the market or into the existing IT infrastructure. So these are the 4 different personas that IBM sees as playing a role in the building of these products. And so with that, IBM decided to build this cloud platform called Watson Data Platform that provides the tools necessary for these different individuals to do their jobs. So just spending a moment on this slide here, I actually did a lot of this in this project myself using Data Science Experience. So I ingested the data into my notebook environment to develop it. I analyzed it using open source scripting languages. In this case, it was R. and then I persisted it into object storage, the model and some data sets. I wound up storing that somewhere, and then finally I actually was able to deploy this model into an application using Data Science Experience as well. Okay. And there's a lot more that's available as part of the Watson Data Platform. There are many, many different products and types of data stores and such, but because this is a machine learning webinar and we're focusing on data science, that's what I'm going to stick to. I'm not going to talk about all those other things. Okay, so in just a moment, I'm going to go into the demo and actually show this to you, but I just want you to keep in mind while I'm going through DSX that the vision and how it was designed was really focused on these three different pieces. It was creating a data science platform that allows this team of analysts, of analytics professionals to continuously learn. And we'll see how that works. Also, we wanted to create it in a way that there didn't have to be compromise on the types of tools that you like to use. So one guy on your team might be proficient in Scala, another guy might be proficient in Python, and someone else might be coming from a different background and they might be using SPSS. So we have all of those things tied together and able to be used at the same time by different people in one team on DSX. And then the last thing is the collaborative features, such as projects and so on. You'll see when I go into it. Okay, so now let me switch over from slides to the demo itself. There's a URL here if you want to follow along when I actually start going through the notebook. I'm not going to do that yet. I'll let you know when I do that. But if you go to tinyurl.com/Airbnb Notebook, I've shared a version of the actual analysis itself that you can follow along with when I go through that. Okay, so I figured a good way to start would be to kind of just walk you through the steps that I took when I did this project. So if you go to datascience.ibm.com and you sign up, this is the landing page this is like the home page that you see. And this dashboard kind of shows you a couple different things. The first thing is recently published articles, data sets, and notebooks on a wide variety of subjects. And all these are part of the community aspect and the learning aspect of DSX. Then I also can see the projects that I've been working on, and if someone has updated something, it'll come to the top of the list. And then finally, there's some links at the bottom to the blog and different resources there as well. Okay, so what I want to do is I'm going to create a new project. This is going to be for my Airbnb analysis. And think of the project as sort of like your workspace in Data Science Experience. This is going to be Airbnb analysis. I could give it a description if I wanted. When you sign up for Data Science Experience, there's a Apache Spark service that's provisioned for you. So I'm going to pick one of those. And there's different types of storage that I could pick. Now let's create this project. Okay. So along with your free Apache Spark instance, you get 5 GB of object storage when you sign up. Okay, so on my project page, I have different assets that I tie together to this project. Okay, so I could have notebooks, which we'll go into in detail. That's sort of where I write my code and where I develop my solutions. We have data assets that can be either flat files or connections to a wide variety of data sources. I can build models with Watson machine learning that can then be deployed via REST API. Not going to do that so much in this demo, but just to let you know the kind of different assets that can be associated with the project. Okay. And then, okay, so let's go and add a notebook. Actually, first, before we do that, let's add our data set. So this data set, as I mentioned, I actually found it on the DSX community page. And when I click on this compass over here, it allows me to search all those assets that are in the community repository. So I'm just going to search for Portland. and I see that, okay, I have Airbnb data for analytics, I got calendar details, listing details, and review details. I definitely want listing details. And okay, it's going to save it to my Airbnb analysis project. Sounds good. And I want the review data also. That sounds good. Okay, so now that's added to my project. Okay, now let's add a notebook so we can actually start to analyze that data. Now there's different ways I can do this. I can create a notebook from scratch. I can grab a notebook from a URL, like one that's on GitHub, or maybe a teammate has one on GitHub, something like that. I can grab it from there and bring it into the project. In this case, I have the file sitting on my desktop, so I'm just going to bring it in from there. So I got predict Airbnb rental prices for Portland, Oregon notebooks. Okay, make sure that I have it associated with the Spark service, and I'll create it. Okay, so while this is happening, the first time this happens, when you create a notebook, you'll see that it's spinning up your Apache Spark service and getting ready for you to actually begin coding. Okay, so here's my Jupyter Notebook. Now, before I actually go into the analysis, I want to take a minute to orient everyone to the Jupyter environment. I don't know who's in attendance, so hopefully this is not old news for everybody. This is a Jupyter Notebook is a document that is a mix of HTML rendered text and then code cells that you can execute independently. And you can run a number of different kernels in the Jupyter environment. So for example, we can code in Python 2, Python 3.5, we can code in R or Scala, and in DSX you can also pick which Spark version you want as well. So up here you see I'm coding in R, the Spark 2.0. That's the kernel that I'm using. Now, these code cells can take on a number of different types. I only use cells for executing code and cells for Markdown, which is the HTML rendered text that I had mentioned before. Just to give you contrast, if I double-click on this cell, it'll go into edit mode. Okay, and then this is where I actually can come in here and start to change the text here and write my whole essay and so on. Then when I click on play, it'll render all this, and you'll see the results. Okay, now a code cell, I'm going to skip down a little bit. Now a code cell is where I execute, or I write my R code, and then when I execute this, the output is not any kind of rendered text, it's actually the output of those commands right below the code cell. Okay, so that's what you're looking at. Now I'm actually going to go through the analysis itself. One of the things, people use notebooks in a lot of different ways. I've seen people use it as a scratch pad, a place to just write scripts and never use a Markdown cell, or you only use a Markdown cell sort of as a header to say, okay, this is this section of my code, this is the next section. But I think you can go way beyond that, and I like to think of a notebook as a narrative, and that every data set and every problem that you're trying to solve usually has a story, because we're trying to figure something out about, there's some context associated with it. So I like to promote the idea of using a notebook as a narrative where it's appropriate. So I'm going to try to do that here. Okay, so so I'm going to read parts of this, and we'll start off with about Airbnb and inside Airbnb. If you want, now is a good time to go to the URL that I showed, so you can follow along yourself. Okay, so recently I had the pleasure of staying at my first Airbnb, a funky, cozy apartment located in downtown Denver, Colorado for $100 a night. This apartment had taxidermy, zombie statuettes coming out of the dirt for potted plants, and Netflix ready to go on the TV. The apartment immediately stood out in stark contrast to the sterile feel of a typical hotel room. Needless to say, I was sold on the idea of using Airbnb for my travels. Now, much like how Uber doesn't own any of the vehicles used by its drivers, Airbnb doesn't own any of the real estate listed on its platform. It's essentially a brokerage between real estate owners and renters. And while users sing its praises, not everyone is happy about some of the unintended consequences. So just like Uber's wrestled with or ignored regulatory issues, Airbnb faces some challenges regarding zoning and other laws associated with rental properties. So for instance, there's a big difference between someone renting out their house while they're going on vacation or someone owning 40 properties in New York City and simply using Airbnb to list them. And how to handle these cases is an ongoing debate. So inside Airbnb is a I guess a company maybe that was, or maybe it's just one person. I'm not sure. But it was created to provide visibility into the practices of Airbnb and the users who list their properties with the company. So inside Airbnb has scraped data from the Airbnb listings and aggregated it into data sets for various cities across the USA and the world. Now, what kind of data does inside Airbnb provide? So there's 3 data sets, and we saw some of this on the community tab. There's the listings, which has detailed information for each listing, reviews, feedback from those people who stayed at each listing, and then a calendar with the availability for each listing. Inside Airbnb actually has sort of a political motivation. They kind of want to point out some of the questionable practices of Airbnb, but I decided to take this data and use it for more capitalist purposes. All right, so what's the question, right? Let's define the question. It's hard to know whether you're getting a good deal on an Airbnb. Using the reviews and the listed price can help, sort of if you're browsing on Amazon, but wouldn't it be better if you could know which properties are priced below or above the market? Maybe there's some listings that have everything you're looking for, but are statistically speaking cheaper than comparable properties. So this was the thought that led me to asking the question that we'll ask of the data. Can we find potential inefficiencies in an Airbnb market by learning how the features of that market impact the price? So you want to save money without compromising on what you're getting. Are there any properties like that? Okay, so now I'm not going to go through the code cells. That's why I shared the notebook. You guys can go through the code cells, but if you're looking, you'll see that that cell above was hidden. And the reason that cell above was hidden was that it had my credentials to object storage. And that's a nice feature of Jupyter Notebooks on DSX, is that I can share these notebooks with other people, but I can hide sensitive code cells, which is what I've done on that link. Okay, all right. So back to the data here. So there are a lot of fields in the listing data. This is just a sample of it. The important thing to take away is that there's data surrounding the price, the size, and the location of the properties. Okay, so the next question is, like, what drives the price? I'm not going to read so much from this point on, but I'll just talk over it. So one thing I like to do is, when approaching a data science problem, is first kind of step back and ask yourself, what matters in this topic? What matters in this area? Before we go forward with like quantitative analysis. So I think when it comes to real estate, we all know that it's location, but it's also size. So the first step I do here after doing some data prep and cleaning is I actually plot the various size. I plot a couple different size metrics and types by price. So if you look at the number of the nightly price, take the log of the nightly price and plot that against the number of people that it accommodates, you see that there's like this stratification. So if you're getting an entire home, it tends to accommodate more people, and the price also tends to be higher. If you're getting a shared room, it tends to accommodate less people, and the price is lower. And a private room is in between, which is intuitive. That makes sense. Similarly, if you look at the distribution of price and you split it out by entire home, private room, or shared room, you get this really, really clear stratification. Again, shared rooms are cheaper, makes sense. Private rooms are sort of in the middle, and entire homes are more expensive. So this intuition is something we're going to want to build into our model, right? We're seeing that the data is telling us that what affects price, definitely size. Okay. The next plot here is, what about location? Let's look at rental prices, the average rental price by neighborhood. And what does that look like? So this is just a sample. There's over 90 neighborhoods in Portland. This is just a sample of neighborhoods, and you see that, you know, the price can vary from $168 all the way down to $76 on average. So again, location clearly plays a role here. We're going to want to incorporate location into the model as well. Now, just as a little interlude, I have a couple things here that I discovered when I was exploring the data. One is that you can actually rent a yurt in Portland, and I didn't even know what a yurt was. I had to look this up. But I mean, this is a very charming little hut here that you could stay in Portland. They also had entries for an earth house or a tree house. This just goes to show you that, you know, it's not just Denver, and it's not just, you know, quirky in Portland. Airbnb has a lot of good stuff to offer for people traveling and wanting new experiences. So I thought that was pretty interesting. However, this did have a practical effect on machine learning. I don't want to model the price of a yurt in Portland. That's too particular. There's not going to be enough to generalize, not enough observations to generalize. So any of these, like, you know, quirky, singular type of properties, I just rolled up into one category called other. You know, we're just going to group them all together because they're all strange and unique. The other thing I found was pretty interesting, that some places are listing, some businesses are actually listing their properties on Airbnb. So if you look closely here, you'll see this property, it accommodates 16 people. That's what it says. It has one bathroom and it has no bedrooms, but it has one bed. So none of that makes any sense. When you read the description, you see that it's just a business that's promoting itself and offering to, you know, rent out their space for a business function or a meeting or something like that. This was throwing off my model because it was trying to, you know, it was taking large accommodation with 0 bedrooms as a valid data point. But for a renter, that's not a valid data point. So these have to be taken out. So I did that here. If the accommodates value is greater than 8 and it has less than 2 beds, or less than or equal to 2 beds, like, that is not a valid data point, in my opinion. Okay. All right. So and this is all in preparation for you know, building a nice model. All right. Now the next thing is that Portland has 90 neighborhoods, and there's not a lot of observations in each neighborhood. So I had to, if I wanted to use a model that took into account the location by neighborhood, then I was running into a similar problem with having a neighborhood with like 2 or 3 listings in it, and then any kind of coefficients for that neighborhood would be, you know, dubious at best. So what I did was I used the lat long for each. I grouped the data by neighborhood, and then used the latitude and longitude for all the properties in that neighborhood to find sort of like the average latitude, longitude for that neighborhood. And once I have that, I could find the closest neighbor to that neighborhood that had very, very few listings, and then merge them together. So if you can think about it as like the neighborhoods that have very, very few listings get swallowed up by the ones closest to them. And I plotted this, so you could see here, this is using lat long and using the neighborhoods, the average lat long for each neighborhood. This is sort of before you do that consolidation. This is what the map looks like, and then afterwards, this is what it looks like. So ideally, I would want this process to run until each neighborhood had at least, you know, like 30 observations in it or so. But writing the code for that was challenging, and I ran out of time because it was only 2 weeks. So I had to kind of stop after one iteration. But it still does help. It still does kind of group things a little bit more sensibly. All right. So now the data is pretty well cleaned up. I think I've gone through and gotten rid of some big stumbling blocks for the model. The next thing is, let's pick the features from the data set that we actually want to use for modeling. A couple things I did here. One was take the log price instead of just the absolute price to deal with skew of prices. And the next thing was we created this, with the help of a friend of mine, we created this new feature called composite size, which is, the way to think about this is, you know, there's obviously a strong correlation between number of beds and accommodations. So we want to try to reduce the amount of collinearity that exists in our model. So the way we did that was we created a simple regression model of the various accommodation-related variables to the price, and then we incorporated that as like a composite variable into the model. And when I was playing around with the predictive power of the model, it actually did help improve it. So we kept it in there. Okay, and then the last thing is we got to pick the features that we want to include in the model. So I pick only those associated with location and price. Location, price, and size, like we spoke about. Okay. I'm not going to go through too much here because we still have a little bit more to cover. I chose a mixed effects regression model over something like random forest or XGBoost or other popular and powerful algorithms because mixed effects models allow you to control for groupings very nicely, and it allows so for example, it allows you to say, I want the coefficient for bedrooms to vary by each neighborhood, which makes sense because as we saw before, a bedroom in this neighborhood might contribute more to the price than a bedroom in another neighborhood. So there's a link here, and I have a link at the bottom also to some very, very good documentation on how to build models like this and how they work. So this is what I chose, and when I evaluated it, the first R-squared I got was 0.51, which is okay. Not tremendous, also not terrible. Sort of depends upon the domain that you're working in. If we evaluate the model visually, hold on, sorry, there we go. If we evaluate it visually, it actually looks pretty nice. Take a look at the predicted versus actual prices. If you take a log, there's like a very nice, strong correlation between both of them. As the actual price goes up, the predicted price goes up as well. So that's nice. And then beneath that, we see that the residual plot is also very pretty randomly distributed, which is what we want to see in a residual plot. So it's pretty happy with these results. Now, this last plot in the bottom left corner here is plotting the predicted value from the model, the predicted price point, and then the 95% confidence intervals of that value, or prediction intervals. The green dot is the actual price of that Airbnb. So for many of the properties, the model did pretty well, either right on the dot or very, very close. For some of them, though, the actual value was above. So this is what I would consider to be mispriced. If it's outside of the 95% confidence interval after generalizing on the whole market and taking into account the neighborhood and stuff like that, if you're still outside that price or either above or below, then that's mispriced. Okay. So then I train the model again on the whole data set, and my R-squared goes up when I test it on just a small validation set. So that's nice. And then now that we've sort of come this far, and we've created these confidence intervals, and we've identified the points that are above and beyond it, we can plot all of this on a map, and we can color it based on being above the confidence interval or below the confidence interval. So if it's below, then we're going to say it's underpriced, and if it's above, then we'll say it's overpriced. So this is like we're getting closer, much closer towards an actual product here, right? This is useful. Okay, but before I can go on, I need to actually export the model that I've created in R, and I also want to export the validation data set for my Shiny app that I'm going to show you. So the way that I do that is by getting the credentials for my object storage, so I'll skip over, and then it's just a couple lines of code to write it out to your object storage that you get with DSX, and then from there I can pull it into other applications or other environments. Okay, and that is the end of the notebook analysis. Now I can go and show you the actual app itself. So there's two ways you can do this. First way is if you come up here to Tools, DSX actually comes with an instance of RStudio. So I've already opened that over here. And the way that a Shiny app works is that typically you have two scripts. You have a UI script for your interface and how the app looks, and then you have a server script that actually runs all the computation behind the scenes. So I developed this in our studio on DSX, and then I can run the app by clicking Run App. I'm not going to do this now because of time constraints, but I want to show you how the very last thing I did here was I actually deployed it. I deployed this Shiny application to shinyapps.io, which is run by our studio. So I was able to deploy this to shinyapps.io from inside of DSX. I can also launch it and run it from DSX, but then it's much more temporary. It's not hosted anywhere. Okay, so now if you want, you can just wait. This is the URL. Wait until the webinar is over, if you don't mind, to go to this URL and play around with the app. But I'll show it to you right now. Okay, so let's reload this page and get the app going. Okay, so I haven't mentioned this yet, but Shiny is a web app that you can build in R. And what I've done here is I've taken the same, it's sort of the same lat long, all the same data that we worked with in the notebook, but now I've used Shiny and I've plotted it here on this map and made it interactive. So now I can know like which neighborhood I'm going into. I can click on an Airbnb and it'll give me a lot of different information. The first thing when you'll see when I click on an Airbnb is that it'll give me details about the listing, which neighborhood it's in, the prices, beds, baths, etc. But then we make use of that model and we actually get the predicted price range. Okay? And then I can compare and say, all right, well, how close is this to the predicted range? Now the next thing that I didn't talk very much about I didn't do any of this at all in the actual notebook, but that reviews data set, I took all the reviews for this listing. When you click on a data point here, it will concatenate all the reviews for that listing, send them to the Watson API that will return back to you a lot of information about those reviews, like the type of sentiment, different emotional signals for different emotional content. And then most interesting to me, and I thought was actually very helpful, is it'll give you these like keywords, the things that were most talked about in the reviews. Okay, so let's look at some of these mispriced ones, because that's where I would want to stay. Okay, so the listing price is $50 for this one, and the predicted range is 73 to 259. 2 beds, 2 baths, accommodates 4 people. It's an entire apartment. That sounds great. This sounds like a really great deal. It sounds like it's undervalued. If I come over here, let's click on a red one over here. Oh, I got to zoom in a little bit to get that one. Let's try this red one over here. Okay, so this is another interesting case. It's right at the very, very top of the range. So this one, perhaps you're not getting such a good deal on that one. I know there's one more over here. Okay, so this one's listed at 250, but the predicted range, the max is really 214. So yeah, this might be one you would want to avoid. But maybe you know more about the neighborhood, or maybe that is a good deal. But this would be one that I would want to keep looking for other things nearby. Okay, so that's as a consumer. This is how I could use this model as a consumer and help me find good deals. But now, what if you're an owner and you want to price your property and get the most value? So that's pretty simple. All we have to do is we have to take as input the same types of fields that we built the model on, feed it to the model, and then it will return back to us a predicted price and the intervals. Okay, so let's come up with a hypothetical case here, right? A bed and breakfast in Irvington. Let's do a shared room. So we got 1 bedroom, 1 bath, and accommodates 2 people. Okay, wow. So that should be priced. So let me explain this plot to you. This is also a function of not having enough time to make, in 2 weeks to make the plot like super nice. the blue box plot you see is the distribution of prices in the neighborhood. And then the green dot and the line are the predicted price and the confidence intervals. So this is basically telling you that for the market, you would be way below market. But if we went from a shared room to, let's say, a private room, which are more expensive, then all of a sudden now, okay, well, your property is really valued sort of at the 25 percentile of that neighborhood. But it could be, depending on how nice it is, or depending upon how much you want to get away with, you could price it kind of up to, this level. But you wouldn't really recommend going beyond that. And let's say instead of a bed and breakfast, we were getting a house, and we were getting the entire house. Add some more features, add some more size to it. Okay, so then yeah, the price jumps up, and there's not a lot in the Irvington neighborhood that's like that. Okay, so that is pretty much the demonstration. I'm going to come back to the slides now. I have to find the slides, so there they are. Okay. How much time do I have? Okay. All right, so now let's summarize and come to a conclusion. Okay, so we did machine learning and data science experience on the Watson Data Platform. We had some very strong results, I think. We were able to maximize profit and efficiency in a way that benefits both owners and consumers. We saw like a very flexible platform that allows us to ingest data of different types, and we can deploy models in different ways. You saw the way that I did it was using R and Shiny. And in general, I think you could see how Watson Data Platform accommodates the different personas on the advanced analytics team. And just to remember some of the steps that we went through, we started off with projects. I didn't really talk about permissions. It was my bad. I forgot. But when you can add collaborators to your project and assign various permission levels. I did go over data connections, different types you could have. You saw everything I developed was using open source libraries in R. So I think that's some of the best of open source that's incorporated into DSX. I persisted the data and the models. You saw how I deployed it, and then you also saw how I could incorporate Watson APIs into my Shiny application. And there were a lot of things that I didn't even get to touch on that are part of DSX. Like I didn't need to use Spark because it was a small data set. If you had a very large data set, that would be it's there for you. It's ready for you. There is GitHub integration. I did this project by myself, so I didn't have to make use of that. Could have used SPSS for building models, or we could have used Watson Machine Learning and trained a model with Watson Machine Learning and deployed it that way, and then use the REST API to score the incoming records for pricing your property. Okay. I just want to point out that IBM was recognized earlier this year for having the leading data science platform from Gartner. And that's a combination of the ability to execute on projects and also just like the overall completeness of the vision. And I hope that I've showed you a piece of that today. So if you want to sign up for the data science experience, it is free. Like I said before, you get Apache Spark and 5 GB of object stores for free. I believe that the trial period is 30 days. And this is sort of just, again, an overview of a lot of the things that I showed you and some of the things that I didn't have time to show you or weren't relevant to this project. Okay, so that's my presentation. I know that I ran through a lot. I hope there are questions. Here's links to the notebook and the app. Watson Developer Cloud is where you can go learn about all the different Watson APIs that are there, and there's extensive documentation and examples and demos that you can play with. And I wrote a notebook that shows you how you can access that in R. So that's the Watson NLU and R link. And I would check the Data Science Experience blog for seeing what's new, what's coming out, and things like that. So that's pretty much it. That's pretty much all I had to share with you all today. I hope it was informative, and I hope that you saw how we could, build a data product using Data Science Experience. So Anna, if you want to see if anybody has questions, that would be great.
Yes, so we have a question right now. Can I know why R and not Python?
Sure. I had to work quickly, and the language that I'm the most proficient in and can work the fastest is in R. If there was a looser timeline, then a lot of this I could have done in Python.
Do we have any other questions? I don't have any questions right now in the chat room. Yes, one here. Can we use Flow as opposed to create a model in R?
Good question. So Flow is the SPSS integration for DSX, and you can build models in SPSS. But my background is more in open source, so I'm hesitant to say definitively about how you would deploy that using either Watson machine learning or how you would incorporate it into a Shiny app. But yes, you can build models in SPSS using DSX. But the deployment part is the part that I would have the question.
Do we have any other questions? I guess not. Thank you so much, Rob.
Right.
Thank you everyone for joining us.
Yeah, you're welcome. Thank you all for your time. Please feel free to reach out to me if you have any questions as they come up.